Hi guys, this what you see is an old laptop battery. Well, I got a few of these from the laptop repair shop, and I have many such others in my warehouse. Now guys, the plan is to extract the lithium ion batteries from these old batteries and reuse them by making a very large and powerful battery pack, 12 volts. So let's open these up. So guys, although they might be weird looking from outside or very old, but from inside they are as good as new, at least from the look. Although the batteries are obviously used ones, but still bright and shiny. So let's check their voltages, if they are working or they hold some voltage at present. And here you can see that the battery is still alive, even though highly discharged, but it is alive. Let's go to the next one. Wow, this one is also alive. That is very nice. All the batteries are alive.
It was now the last.
Wow, this one is also alive. So yeah, we are doing good here. Now I have to extract the batteries from these and also open the remaining battery packs. Now guys, removing the battery from the case is not that difficult, but separating the batteries from each other is. So let's first remove it and then I will show you how to do that. Actually, in some cases the batteries are glued to the plastic base for better stiffness. Yeah, one is a bit loose now, at least these two. Got this one out successfully. You see, this was the glue that was sticking these batteries to the case. Now let's jump to the other one. Move it like this, because if it touches this, then it is going to make a short circuit. Okay, you see this part done, and now we can cut off this one. Only insulation left. So this is also done. Now this is guys plastic insulation, and guys here I've got now Samsung batteries 18650 2600 mAh. So the same way I'm going to extract the rest. So guys, this is the spot welding machine that I'm going to use to make the battery pack from old laptop batteries. So guys, these are the old batteries extracted from the laptop batteries, and this is the foot switch for operating the machine. So yeah, let's get on with it. So guys, here as you can see that the batteries have been welded to each other, although these two are separate. So I have to keep them steady, and for that I'm going to use these zip ties. So yeah, let's do that. So guys, here as you can see that the battery is pretty rugged and steady, and this holder that can hold 20 batteries in total on its either sides, you can buy that from the link provided in the description. And now I'm going to make 3 such sets, and this set is going to be 3.7 volt, same as the upcoming 2 sets. So guys, the good news is that all the 3 sets are almost complete now. You can see this set is completely connected in parallel, the upper one, and the lower one is also connected in parallel, and same on the back side, the negative side. Although these 2 sets, 10 on this side and 10 on the lower side, are not connected to each other yet, so that I have to do still. Remaining everything is done. Also the zip ties that are holding the battery is pretty good and stable. So let's do that, and before we do that, let's measure the voltage of individual sets, like this one first and then this one, and same for the others. So the voltage of the first set is 3.42, lower set is 3.46, almost the same. Upper set 2.81, very discharged. Lower set 3.52, yeah, it's fine. Upper set 3.44, fine. 3.68, pretty good charge. And guys, there is also one more cool idea, that if you are going to stick the strips to the lithium ion battery pack, then you can use neodymium magnets for stability. I will show you. Now let's say I'm going to give a jump from this point to this point. So connecting the magnet over here, yeah, like this. Actually I have to connect it on the other side, on this side. And then this strip will stick to this part without falling, irrespective of the fact that it is really long and the gravity lies somewhere here, so it is not going to fall. And after that, simply do the welding. Now after this part is stuck, it's not needed anymore. Yeah, you see, pretty good jumper welds. Let's make this one, the end one, also stable. You see, it is sticking. Always do the last ones, because you are going to tie the zip on the middle, so they are already steady. The last ones need a little more attachment, so the strip is going to help in that as well. So guys, the positive cables have been connected, 1, 2, 3 and 4. Now comes the negative jumpers. So yeah, the negative side has also been welded, 1, 2, 3 and 4. So this set is finally complete now. Now same has to be done on the other 2 sets. So guys, the parallel connection of the batteries is also complete now. You can see I've given 4 on the positive and 4 on the negative for all the battery packs. You see, 4 for each. So now I have to connect all of them together with the help of this balance charger circuit for lithium ion batteries, which I got from Banggood's. Link for this will be provided in the description. You can see it can handle a maximum current of around 40 amperes, so which is the target, 12 volts 40 amps battery pack. So let's open this up. Nice. Circuit looks pretty good and well constructed. 40 amperes, 12.6 volts, and you can see here printed 0 volts, 4.2, 8.4, and finally 12.6. And plus minus, these are the final main output terminals as well as the charging terminals for this battery pack. So guys, this what you see is a 2 meter long and a pretty good spacious heat shrink tube for batteries. So this is what I'm going to use to seal the battery pack. Link for this will also be provided in the description, guys. Okay, so guys, the battery pack is almost ready now. All I have to do is attach this circuit, the final circuit, and then it's complete. So for doing that, we will have to first figure out which one is the final positive and which one is the final negative out of these 4 wires. So for that, I'm going to use this multimeter pointing towards 20 volts DC. I usually keep black as negative and any other color as positive. So if it shows 12, then yeah, I mean more than 8 volts. So yeah, as it is showing 10.41. But one thing is different. Black is not negative. You can see the negative sign. This indicates that black terminal is positive. So it was a good thing that I rechecked it before actually soldering the wires. And here on the circuit you can see 0 and 12.6. So the black terminal will be connected over 12.6 and blue will be connected at 0, being the ground. Okay, so let's do that. So guys, 12.6 has been welded. So guys, now that the 2 thick wires have been connected, positive and negative 12 volts from the battery pack, the main 2 wires, now we have to find out which one is the 4 volt wire and then which one is the 8 volts wire out of these 2. Okay, positive, yeah, this one is 4 volts, the upper smaller one, and this one should be 8 volts. Yeah, almost 7 volts, and it should be 8 volts if it's fully charged. So the upper one is the one we have to take. Now we are going to connect this 4 volts wire at this point, 4.2. Okay, so let's do that. Yeah, yeah, perfect. 4.2 also connected. Now the last one is 8.41, although it is discharged, so it is showing 7 volts, around 7 volts. Yeah, and this also done. Now the final 2 wires are needed for running this battery pack, negative and positive, the main output. Okay, so let's connect them as well. So guys, as you can see that the positive wire has been connected. You can see here in the positive terminal, now the negative, which is going to be the black one. On the other hand, I have connected this tape just to prevent short circuit. So yes guys, all the wires have been connected. Okay, so guys, the battery pack is fully complete now, and you see these are the 2 terminals, blue for positive and black for negative, the final output with which we are going to connect or run a load, plus also going to charge this battery pack. Now this is a car headlamp bulb, 55 watts, although it runs at 12 volts, and the battery is discharged showing around 10.3 volts or 4 volts. So let's give it a try. You have to be careful not to touch the 2 terminals together. Okay, I think these 2 terminals should be the one then. Yeah, you see that the battery pack is working. Perfect. Pretty good, right? As you can see that it is running great. The circuit is really efficient. Link to this product will be provided in the description, and the cost is only around $2 or $2.5. which makes it around 160 rupees. So guys, now comes the part of charging this battery pack, for which I'm going to use this 17 amperes power supply and the variable display voltage range from 0 to around 16 volts. So guys, the maximum voltage that this battery pack can intake for charging itself is 13.6 volts and a minimum of 12.6 volts. So I have a range of 12.6 to 13.6, which I will have to set on this power supply and then feed it to the battery pack. A link for this will be provided in the description, guys. So first step is to turn it on. Supply turned on. As you can see, the voltage displayed over here is 14.3 volts. I will bring the camera closer. You see 14.3 volts. I have to bring it down to 13.5 or 13.6. Yeah, for safety purposes I'm going to keep it on 13.4. Yeah, 13.4 should be fine. You see, so let's connect it to the power supply. This is red, making it positive, and this is blue, again making it positive. So guys, positive has been connected to positive. Now comes the negative. So there is sparking, but there is no voltage drop, which means the charging speed is exactly what we need here. Yeah, little voltage drop, 0.1 volts. Yeah, and increasing, 13.2. Let's also measure the current flowing through the battery pack with the help of this multimeter. 10 ampere mode. This terminal has been connected of the multimeter. Now comes this one. The current is good enough, 3 amperes only. And when I will remove these two terminals, because the current is flowing through the thin wires of this multimeter, the current is obviously going to increase from 3 to at least 5 amperes. As you can see that I have directly connected it with a clip, and the voltage has dropped to 13.1 volts, which means large current is flowing to the battery pack from this power supply. Otherwise the voltage drop won't be that high. Cool, right? So let's see how long it takes to fully charge and then measure the voltage afterwards. So guys, now that the battery pack is fully charged, now let's measure the voltage. And guys, to measure the voltage of the battery pack, I'm going to use this type of multimeter instead of the traditional old multimeter. I will give you the reason as well, but let's first measure the value of the battery. So pointing the meter towards voltage mode. Okay, auto power on. At present it is showing MV, which is millivolt, 0 millivolts. Blue terminal for positive, red positive, and black for negative, and again black for negative. Connecting it, and here you see that the voltage displayed on the screen is 12.12 volts, almost full. The full voltage is 12.6 volts and it cannot go beyond that with the help of this BMS circuit board. So this meter shows it's more than 12 volts, it's fully charged. Okay. Now if I give the same measurement with this type of multimeter, although the display is quite a lot more visible than that multimeter in the daylight, still the accuracy of this meter is not that good, obviously because it's really cheap. Now according to this meter, the battery is still not fully charged. It's showing 11.91 volts, so around 0.3 volts or 0.22 volts is the error in this meter, because I have cross-checked the value of 12.12 with many more multimeters, and all the multimeters say that the voltage is more than 12 volts. So guys, let's measure the voltage of individual sets, positive and negative. Here it is 0, then 0 is negative, and let's take it to the 4.2 terminal, and it should be less than 4.2. 3.947, almost 4 volts. That's the first battery. Now comes the second one, 4.2 and 8.4. Yeah, 4.064, that is 4 volts. Yeah. Now the third set, sorry, negative over here and then positive here, 4.111. So the third battery pack is the most charged one, the second one is a little bit lesser, and the last one is the least, although the gap between the three is very less, and it keeps on equalizing with time with the help of this circuit board. So that's the individual battery check. So guys, now that everything is done, it comes to the final load testing. Okay, first is the old load. Car headlamp, 55 watts, 12 volts. I'm going to give it another try. Pretty good. Yeah. Now comes the 24 volts, 5 amperes, 43 kg centimeter torque type e-bike motor. Okay, so let's test this one. Yeah, working pretty good. Something really useful from old laptop batteries. It's going to be very useful in many of my future projects. Pretty good. And guys, the super powerful 100 amps e-bike starter motor. Now the peak amperes that it can handle are more than 80 amperes. So it can obviously handle this load, but not for long. For going more than 40 amperes continuously, you need to provide an additional heat sink over this. Okay, so I'm not going to go beyond that for a long time. So I'm just going to test it anyways. Okay, you see, pretty good amperes, right? Oh, super high current. I'm pretty sure that it can start a bike without any problem. Working really nice. And guys, now comes the time of testing this DC drone motor with this battery pack. Okay, both are 12 volts and the maximum current for this motor is 22 amperes. Okay, so guys, get ready. Oh, 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 it is taking my hands up. Pretty good thrust, I tell you. Yeah, it might just take this battery and fly. And for that, I'm at least going to use 2 of these in the future project. 2 identical. Okay, so guys, this was the video of this battery pack constructed from a few old laptop batteries. In total 60 pieces of the cells. So that's all for today's video, guys. Thank you so much for watching it. Please hit like and don't forget to share and subscribe. And if you have any queries, you can always ask them in comments, and link for all the products that I showed you in this video will be provided in the description. Thank you.